weaving solar technology into every sunlit surface. Our cutting-edge materials turn facades into micro-power plants, blending efficiency with aesthetics. As the world's largest building-integrated photovoltaic manufacturer, our Ontario plant crafts over 25,000 square feet of sustainable materials daily. From design to installation, Mitrex powers a brighter, greener tomorrow. Join us in shaping the future.
Hi, everyone. We're just going to sit back and hang tight for a few minutes while everyone joins us. In the meantime, if you need a washroom break or a quick coffee break, feel free. How's it looking? Let me just check with our studio manager, see where we are. Give me the A-OK. Good to go? All righty. Well, hello, everyone, and welcome to our LinkedIn Live BIPV in action at the 18 Queen Street building in Kingston, Ontario. I'm Terry Oswald, and I'm very excited to have you with us today as we dive into this incredible project. So today's program includes a video tour of the new building and an interview with our project manager, Berang Baluri. We'll also take a closer look at Mitrex's building integrated solar solutions and wrap up with a Q&A with myself, Corey Fry, our sales director. There is a Google form available throughout the event, so if you'd like to receive a marketing package, please keep an eye on the comment section as our team will be dropping the link there. Also, the form will be available for 15 extra minutes on the description of this event, so you can fill it out once the event is completed. Besides, we'd love for you to drop any questions in the live chat so we can answer them during the Q&A. So let's get started. First up, join me for a quick tour of the 18 Queen Street project.
Welcome to 18 Queen in Kingston, Ontario, a project that shows how a building's exterior can do more than just look good, it can perform. This mid-rise mixed-use building, developed by Homestead Land Holdings and designed by Rod Leahy, was conceived with a focus on long-term durability, strong architectural identity, and improved energy performance. From the beginning, the team faced a familiar challenge. How do you integrate renewable energy into a building without compromising the design? The facade spans multiple elevations, and the goal was to maintain a clean, modern appearance while meeting performance requirements and keeping installation straightforward for the construction team. The solution was to fully integrate solar directly into the building's envelope. Across 6,000 square feet of facade, Mitrex solar cladding is installed on all 4 elevations. Visually, it's a seamless dark gray panel system, but each panel is also actively generating power. Behind the surface, the system combines Mitrex eFacade Pro panels with the CladdShield rain screen assembly. This creates a complete wall solution, including continuous insulation, subframing, and an integrated air and moisture barrier, all designed to work together. And because it's installed using conventional rain screen methods, it fits naturally into standard construction practices without adding complexity. From an electrical standpoint, the system is designed to integrate cleanly with the building's infrastructure. The facade panels are grouped into strings that run discretely through the wall assembly, with concealed wiring routed to a centralized inverter located in an electrical room. From there, the generated power is converted and tied directly into the building's electrical system, supporting common area loads and reducing overall grid demand. The result is a 37 kilowatt solar facade, expected to generate over 22,000 kilowatt hours of clean electricity every single year. That means the building isn't just consuming energy, it's also producing it. What makes this project stand out is the set of decisions behind it. Instead of treating solar as an add-on, the team chose to make it part of the architecture. They prioritized a system that delivers both enclosure performance and energy generation while keeping installation practical and the design intact. At 18 Queen, the facade doesn't just define the building's appearance. It contributes to its performance, its efficiency, and its long-term value, setting a clear example of what's possible when sustainability is built into the design from the start.
Wonderful. So now that you've seen the building on site, I'm going to take you behind the scenes to show you how it all came together. And after that, we're going to hear from Biron Balouri, Matrix's project manager, and then wrap up with Q&A. So stick around until the end, and remember to ask your questions in the chat and request a marketing package. So for those of you who aren't familiar with Matrix, we are a Toronto-based manufacturer specializing in cladding materials, including building integrated photovoltaics, or BIPV. BIPV is a technology that combines a building's exterior facade with solar technology, so it looks and functions like a normal wall while producing energy. We're proud to be the world's largest BIPV manufacturer with more than 25 years of experience in cladding and construction. Behind me is our advanced manufacturing facility, capable of producing 25,000 square feet of solar material every single day. Our team of architects, engineers, and project managers supports every stage of a project, from feasibility studies and energy modeling to full turnkey solutions. We work closely alongside project teams to deliver systems that meet their unique goals and constraints. Our journey started in 2003 with GCAT Group and continued in 2014 with Cladify, where we pioneered lightweight cladding solutions. And in 2019, Matrix was founded to seamlessly integrate solar technology directly into building materials. So far, we've installed over 25 million square feet of facade materials across more than 700 projects, with another 1.6 million square feet underway. Last year, we set a Guinness World Record for the largest BIPV solar mural. This year, we will complete North America's largest BIPV building with the University of Toronto, as well the largest BIPV building in Dubai. At Matrix, we offer a full suite of envelope solutions, from solar cladding and solar railings to solar glass and traditional non-solar facade systems. Our solar cladding systems like eFacade Lite, eFacade Pro, eFacade Pro Plus, and our newly offered eFacade Tilt come in a wide variety of sizes, colors, finishes, and even projections, so you can match the vision for any project. Our solar railing systems replace conventional systems, and our solar glass can be used in IGUs, window walls, and curtain walls. Our traditional cladding materials include stone, brick, porcelain, aluminum, as well as prefabricated and large format systems. Here's where BIPV tends to have the biggest impact. It's especially effective on projects with large facades and where sustainability is a key goal, whether that's meeting ESG targets, local mandates, LEED certification, net zero goals, or simply committing to environmental stewardship. But BIPV isn't just about sustainability. It's also efficient to install, low maintenance, and built for long-term energy performance, making it a strong fit for both new construction and retrofit projects, particularly across high-rise residential, universities, healthcare, airports, and other institutional sectors. 18 Queen is a luxury rental residence that represents a new generation of sustainable urban living. BIPV transforms part of the building envelope into a clean energy generating facade, seamlessly integrating renewable power into the architecture without compromising the refined aesthetic. While design assist services were not required on this particular project, it is an area where we can add significant value. Our design assist process starts with an initial consultation and solution exploration to identify the best BIPV strategies for each project. From there, we collaborate closely through design development, engineering, and energy analysis to align performance and aesthetic goals. We also offer prototyping and testing to validate solutions early on, followed by prefabrication and logistics planning for streamlined execution. Finally, our team provides implementation support to ensure a smooth installation and successful project delivery. The final design incorporates 6,000 square feet of BIPV material, resulting in a 37 kilowatt system size. To put that into perspective, that's enough energy to charge an EV to drive 110 to 125,000 kilometers. Enough electricity to run about 1,100 LED light bulbs continuously for a year, offsetting 9 to 11 metric tons of CO2 yearly, 1.7 to 1.8 million iPhone charges per year, and planting 150 to 180 trees and letting them grow for 10 years. We're proud at Mitrix to operate the world's largest BIPV factory, equipped with fully automated cutting-edge technology. We have achieved an A2 fire rating, and our products have passed other tough certifications like NFP 285, ULS 134, IEC 61730, IEC 61215, plus Miami-Dade County hurricane testing. All of this is backed by a 25-year warranty covering both product quality and energy performance. At the 10 Queen Street project, the panels were installed using a conventional rain screen system. This keeps air pressure balanced, prevents water intrusion, and allows the building to breathe. The system works for both new construction and retrofits and can be installed as stick-build or prefabricated, keeping installation efficient and straightforward. For the electrical design and installation, our in-house engineering team supported the system layout. After the panels are mechanically installed, the electrical system is configured like a conventional solar installation with standard components such as DC optimizers, inverters, a panel board, and a disconnect switch. The system supplies energy for on-site use, with excess power exported back to the grid. Real-time monitoring software enables continuous performance tracking. So to round this all out, this project illustrates how architecture and technology can work together to create meaningful impact. It's not just about adding solar panels. It's about designing a building that performs beautifully and sustainably for decades to come. Through BIPV, the project sets a new standard for sustainability leadership, enhancing energy resilience, lowering long-term operating costs, and aligning with the next generation of green building standards on the path to a net zero carbon. The vertical BIPV panels are more than functional. They are an intentional part of the building's expression, merging form and function in a way that redefines what solar architecture can be. Now we're going to join Birang Belluri, Mitrix's project manager, to understand the project from his perspective. Don't forget, if you'd like a Mitrix marketing package, just fill out the form that is being shared in the chat.
My name is Birang. I'm a project manager in Mitrix.
From a construction standpoint, what were the key installation requirements for integrating Mitrix solar facade in this project, and how did it compare to a standard cladding system?
From the construction status, there's no big difference between our system or regular cladding system. The major difference is the electrical part. Like we have framing insulation and panel installation. In between of the framing insulation and the panels, we have the wiring part, and also the inverter installation and connecting those wires to the building's electrical system, going parallel with the panel installation at the same time. So in total, there is no big difference, just we have another part called wiring and electrical parts.
And what level of coordination was required between the facade installation and the building's electrical system?
All our design and drawings and the system that we create are based on the drawing and design that we receive from client and their consultant, like electrical, mechanical. We design our system based on their system, such as like panel layouts, wiring, based on their electrical room or the power that they need. We are doing this design based on our system.
And Mitrix has different installation methods. What drove the team to utilize the Clad Shield rain screen system for this particular project?
For this project, we have different systems. For this project, based on the design and the material that they used in the building facade, concrete, dense glass, and window wall system. The best system that we could use was rain screen. It helped us to have the maximum air and water barrier, so it was the easiest way to install our panels.
How did Mitrix support coordination between the design team, consultants, and on-site trainings throughout the project?
So, as I said, our design from our electrical team and also our design team was based on the design that we received from the client. So when you have your system designed completely based on the requirement from client, I believe there's no much problems that we need to solve during the installation.
Based on your experience at 18 Queen Street, what would you tell an architect or developer who's considering a solar facade system for the first time?
So if we can involve with the project design as soon as possible and as much earlier as they can, it would be really beneficial for them so they can have or assist design their system. And it's going to be very helpful and make their job easier to have like a better vision of our system on their design.
Thank you.
Awesome.
Thank you, Brian.
Thank you. That was so great.
That's great. Thank you for sticking with us. We hope this project inspires you as much as it inspires us. Now we can get into our Q&A portion and discuss any questions about the tech design that you might have in mind. If you haven't already, feel free to post your questions in the live chat here. Please welcome our sales director, Corey Fry. Hi, Corey.
Hey, Terry. Good, thanks.
Good. So, ready for some questions?
Yeah.
Yes?
Yeah.
Let's see what we got.
Yeah.
Post away, folks. So Mitrix panels range from 7 to 18 watts per square foot, depending on color and design. What output range did 18 Queen Street land on, and how were those trade-offs between aesthetics and performance navigated with the architect? Well, that's a fairly easy one. It was around 15 watts per square foot, wasn't it?
Yeah, that's right. Right. About 15 watts per square foot on those panels. You could see they're really dark color. Generally, rule of thumb is the darker the panels, the more efficient they are. So those are like a dark gray color. So they're on the higher end at 15 watts per square foot. I guess if there were any trade-offs, it's just that little bit of color to achieve that dark gray. Finish, we brought it down from 18 to 15. But overall, that nice dark gray color is pretty efficient.
Good. And that was a fairly simple process working with the owners, was it not? They understood that the darker the better, and so it was a fairly easy process to go through.
Yeah, that's right.
Great. What's the earliest point in the design process where Mitrix should be brought in, and what does that design assist process look like from first call to completed facade? Wow, the earlier the better.
Yeah, that's usually the case.
Yeah.
Earlier the better. Obviously, the earlier we can get involved in the design process when those decisions are being made. Things like panel layout or overall panel design, overall wall construction design. It's easier when our team gets involved earlier, so we can have input as far as what are the most efficient panel sizes and how to finish returns and how to maximize the amount of space on the wall for BIPV solar generation, that kind of thing. So Yeah, generally, the earlier the better. But with that being said, there's still cases where we can come in late on a project and still make a meaningful impact. As you heard Barang talking about, there's not a lot of difference between installing BIPV cladding and traditional cladding materials. So, even if we were to come into a project in late stages where they've already designed it for a metal panel design or something like that, it would be quite easy to switch that over to a BIPV panel system because it is so similar. But of course, the earlier we can be involved in those design decisions is always ideal.
So, yeah, great question. What's next? More questions? Don't be shy, people. We don't bite. No?
Here we go.
There we go. Oh, sorry. The Cloud Shield rain screen system was part of this project. Oh, sorry.
There was a delay. Now they're all coming in at
Now
once.
they're all coming in. That's okay. That's all right. That means people are interested. Keep them coming. Okay. So what does maintenance actually look like for a building owner at 18 Queen Street over that lifespan? And is there any active monitoring in place? So maintenance is really easy, actually. The system, all of our technology is fairly maintenance free. So you can treat it like a window wall or curtain wall situation where, if you've got a swing stage up there and they're cleaning the windows anyway, go ahead, because it's a glass surface. But is it necessary? No, because of the anti-reflection and the anti-soiling coatings that we apply. So maintenance is virtually non-existent, which is fantastic. And yes, there is a monitoring system in place so that the client will always know in real time what's going on. They'll know what the power generation is on a daily basis. And once the system is up live and running, there'll actually be historical data as well. So if 5 years from now, they want to know what the west elevation was generating on this day, 5 years previous, then they can go to that information and it's there, which is great. Next question. I know there's more. They came in at lightning speed. Patience. It's all right. We're not going anywhere. There we go. Are all panels manufactured in Toronto? What is the delivery time? So, yeah, manufactured, yes. Assembled, all of the customization work happens all under one roof. As we said earlier in the presentation, we're the largest manufacturer in the world. So thankfully, we can do everything all under one roof. So all individual components come, all the customization that needs to happen, all happens under one roof.
Directly behind us.
Directly behind us, yes, yes.
Let's see, next question. Does solar orientation affect the use of live versus passive panels of similar appearance? Really good question. And the answer to that question isn't so simple. It's sometimes. So there are certainly cases where things like the north side of a building or places where a building is going to be in the shade for a majority of the day where maybe it doesn't make so much sense to have BIPV cladding there. We do have panels of similar appearance. We have, non-active panels, or we call them dummy panels sometimes. And you may have noticed on LinkedIn recently, we've actually recently come out with cuttable non-active panels. So it's really great, especially for things like our e-facade light system, where it may not cover edge to edge on the wall, and we can have non-active panels in those areas to finish off walls. Or, in this case, like this question asked, if there's a section of the building that spends all day in the shade, or sometimes on the north facade, if there's not that much sunlight throughout the day, where non-active panels can take their place. Next question, you mentioned that these panels produce approximately 7 to 18 watts per square foot. How does that compare to the building's overall energy consumption?
Well, that depends on a few things.
Yeah, it does depend on a few things. It really depends on, most importantly, how many square feet total are there on a building, right? You may have noticed this project that we highlighted today. There's a larger podium and there's a great big tower there too. Whereas, we're on that middle section of the building. They're not on the entire tower or everything like that. So obviously it's going to offset less of the building's overall energy consumption than if we were, covering the entire tower and everything else. As a general rule of thumb, if you look through our website and you look at some of the completed projects we have, depending on the amount of surface area that's covered by BIPV, usually they're ranging anywhere from, 10% of the building's overall energy consumption up through 30 or 40%, depending on the overall energy needs of the building and what's happening inside of that building, right? We also have projects where, for example, the University of Toronto Scarborough project that you mentioned, where they've done a combination of BIPV cladding and also traditional rooftop solar on that building to, double down on that clean energy generated on site.
Yeah. Okay, next question. How about winters? How will these panels react? Will the weather affect panels? Not really. And surprisingly, they perform pretty good in winter conditions. I think there is a bit of a misnomer out there that, cold weather means less sun and no performance. That's not true, actually. BIPV panels, I would say, perform very well in Ontario. Of course, weather and sunlight hours combined will contribute to performance. So really it's a combination of daylight hours and geographic location. And of course, whenever we're doing an analysis on a building, we take all of that into consideration. So it differs from different building types to different geographical locations.
Are there any examples of Mitrix panels being integrated with other prefab panelized systems or volumetric modular units? Short answer, yeah, there are examples. Using Mitrix or using BIPV in prefabricated wall assembly panels or things like that make a lot of sense. We see a lot of construction going towards those prefabricated wall assemblies these days. And absolutely, Mitrix can be integrated into those systems. And same holds true for volumetric modular units. Again, that's something we're seeing more and more in our industry, modular construction off-site. As we've said a few times already, they're not all that different than traditional cladding materials. So installing them, in a factory really is no different than installing them on site and no different than any other material. So, there are some additional considerations that need to be taken just for the wiring of the panels and those sorts of things and how the modules are going to stack together at the end of the day. But absolutely, BIPV is a wonderful solution for any sort of prefab construction.
Yeah, absolutely. What is the cost per square foot compared to traditional cladding? Well, we get this question all the time. And I say it's kind of like asking, what does a car cost? Well, that all depends. What, are you looking for domestic? Are you looking for imported? Do you want a sunroof? Do you want a moonroof? There are a lot of things that will affect pricing. Design, the design of the building, all those things. However, I would say that as a rule of thumb, you could say we're very competitive with metal panel pricing. I would say maybe 15 to 20% premium on metal panel pricing. That's a good sort of basis to start with.
I'd say so, yeah. And I always like to say premium on day one, right? Because obviously BIPV systems come with an ROI. So
yes,
that premium we're talking about is always just on day one. And then of course they generate energy for the building, offsetting the operating expense. And in a lot of markets that we're in, that also makes the systems eligible for tax incentives, tax credits, local renewable energy credits, things of that nature. So, even if there is a delta between BIPV and a cheaper cladding material, in most of the studies we do, it's quite a short period of time where that delta gets eaten up by the ROI that comes with the system.
Absolutely. I think in our experience, both Corey and I can agree that the average is 5 to 7 years. For payback, and that's if you're not entitled to tax credits. If you can factor in tax credits on top of that, the ROI is a lot faster.
Yeah,
so
I'd say at worst case, that's it for sure.
Yeah. What incentives were applicable to 18 Queen Street specifically, and how was the financial case built for the developer?
I would say the most significant tax incentive available at this project was the clean technology investment tax credit available in Canada. 30% tax credit for the entire installed system based on the cost of BIPV and the clean electricity, and also the accelerated depreciation program where they can depreciate the cost of the system in 1 year versus a typical, I think it's a 25-year model where depreciation usually happens. So here in Canada, where we are and where this project was, those are the two programs that were applicable right away. I know there's a similar program available in the United States. Unfortunately, I think it's coming to an end in 2027. But based on different municipalities, different states and provinces, different countries, there are a lot of credit programs available out there for any type of products that generate clean energy on site, like BIPV. Yeah. So there's almost always something that can be applied to any project that's installing systems like ours.
Absolutely. Wonderful. Thank you all for joining, and don't forget to fill out the form.
Thanks, everyone.
Thanks, everyone. Bye.